Hi there. Today we're going to talk about the third conic section. That's an ellipse. Remember, an ellipse is when the plane crosses through the cone kind of at an angle. It kind of is an elongated oval, or we call it an ellipse. So an ellipse, by definition, is the set of points whose sum to two fixed points, we call those the foci, and that's just plural for focus. And that sum is always constant. And there's some key parts to an ellipse. We're going to talk about the major and minor axis, the vertices. Let's just look at a picture of one. Here you have an ellipse. It's like an oval. And the definition says that the sum to two foci is always the same. So for instance, if I pick a point on the ellipse, let's just start up here and say we go to that focus and we go to that focus. Now since this is all very symmetrical, let's say these are both, we'll just make it up and say it's 10. Okay, so the sum of those two distances is 20. Well, every point on the ellipse then, anywhere I pick, let's say it's right here, when I take this measurement and this measurement, it will always add up to 10. So maybe this is 5 now, and this is going to be 15 units long. It'll end up adding up to 20. I could come down here, this one right here. So maybe this is 8, then this would have to be 12 units so that it adds up to 20. And every single point on this ellipse would do that. I could do that all the way around. Okay, so with that idea, let me get rid of all of that. That's how we get the shape of the ellipse, is from those two foci. Now there's other parts to this. We have two axes. They're axes of symmetry, and you can cut this ellipse in half long ways or short ways, and the longer one is called the major axis. So in this example, this is our major axis. It will always contain the two foci. And then the other axis of symmetry will be shorter, and it'll be called the minor axis. Now it doesn't have to always be an elongated ellipse this way. We might get some ellipses that are tall and skinny. Then your major axis would be vertical. Okay, so we also have this term, a semi-major axis or a semi-minor. So the whole axis is the major axis from one edge of the ellipse to the other. If you just start at the center and go to the edge, that's called the semi-major. Just like a semicircle is half of a circle, a semi-major axis is just half of it. And the semi-minor just goes from the center to the edge. The vertices are the 2 points where the major axis hit the ellipse. So those two blue dots there, those would be the vertices. These 2 points here are called the co-vertices. They're not on the major axis, but they are on the minor axis. So the blue ones are the vertices, pink ones would be co-vertices. All right, let's look at graphing an ellipse. Now, let me go ahead at this point, and I should have mentioned this earlier. This is kind of the light form of the lesson on ellipses. We're not going to really do much with those foci as far as finding exact ordered pairs, as far as where they go. In a more advanced lesson, we'll talk more about where those foci actually fall. We're just going to recognize that they fall on the major axis and not find exact ordered pairs for them. Okay, so with that in mind, we can still do some quick graphing of ellipses. So it's very similar to a circle, and that you see this x minus h squared and this y minus k squared. Okay, that's going to create the center of your ellipse, just like it does for the center of a circle. But an ellipse equation is always set up with fractions, and it will always equal 1. All right, so we'll know what the center is from the numerators, and the denominators tell us how big to make the ellipse. So A and B are the semi-major and minor axes. So A, so this will be A squared is the number you're going to see under there. A by itself is the semi-major or minor. It can change on which one's longer, but since it's underneath the X, it's going to tell you how much to go left and right for your semi-axis. And then this B value here will tell you, since it's underneath the Y, it will tell you how much to go up and down to create your ellipse. Let's look at one. Start off with a pretty easy one because I did not do much in my numerator. I don't have the H and K, which just means my life is simple because this is going to be centered at the origin. So I'll have a center of 0, 0. Okay, and then I look at my denominators. So underneath the x squared, I have a 25. So remember, that's like an a squared. So a by itself would just be 5. Since it's underneath the x, that tells me that my semi-axis is 5 units long. So what I want to do is from my center, I'm going to go right 5, and I'm going to go left 5. And those are going to fall on the ellipse. And then I look underneath my y, it's a 16, so that means my semi-axis is 4, so I'm going to go up 4, and I'm going to go down 4, and with those 4 points right there, I'm going to create a nice ellipse. Okay, try really hard to make it look nice and curvy, like a nice, okay, that's not real great, but there you go, there's your ellipse. Okay, I might clean that up just a hair. Let's make that a little better right there. All right, so that's how you sketch your ellipse. And then we look at which one is the longer one. So since we went left and right 5, and that was the longer distance, so my my major axis is 10 units. So then I know that my foci are going to fall somewhere in here. I don't really know where. I'm not going to worry about exact ordered pairs, but I know that they would fall there. So if you would just put those foci in there so that we know which axis they fall on, we'll call that good. Okay, let's try another one. So looking at this one, I threw some stuff in the numerator. So now you can see you've got some shifting going on. So your center should be at 4, -2. So let's plot that over 4 down 2. That's the center of my ellipse. And then I look at my denominators. So underneath the x is a 16. So that means I'm going to be going left and right 4 to create the ellipse. And then underneath the y is a 49, so I'll go up and down 7. And with those 4 points, let's go ahead and draw our ellipse. Now this ellipse is elongated more up and down, so now your major axis is a vertical major axis, so your foci will fall on that, and so you just throw those in there somewhere. The skinnier your ellipse is, the closer to the vertex those foci get, and really it's usually towards the edge of the ellipse. It doesn't really get that close to the center. As these get closer towards the center, it's going to make your ellipse more rounded until they keep coming in, and when they both hit at the center, all of a sudden your ellipse is going to be a circle. All right, let's try another example. Okay, last one. How about if we pause the video on this one, you go sketch this ellipse on your own. I'll wait for you. Okay, hopefully yours looks like mine. My center should be left 1, down 4, and then I should be moving left and right 2, and up and down 5, and then since it's up and down longer that direction, then your foci should fall somewhere on your major axis. That's the vertical axis. Okay, let's try one more thing. Just like with the parabola and the circle, we also want to come up with that equation if we have some information. Okay, so on this one, I know where the vertices are on my ellipse, and I know how long the minor axis is. Could I come up with my equation? Well, let's try it. I always find it's helpful to sketch a picture of what's going on here. So let me start off with some axes, and you don't have to have an exact graph to do this. If you want to download some graph paper, you can do that. My vertices, remember that's where my major axis hits the ellipse, are at 0, 0, and way over here at 10, 0. Okay, so since that's my major axis, that's my longer one, and so I know that my ellipse is going to look something like this then. All right, so from that information, we should be able to find our center. What's the center of those 2 points? And so you should figure out that that's 5, 0. All right, the other piece of information they told me is that the minor axis is 8 units long. So this is my minor axis, and if it's 8 units, then that means I went up and down 4. Okay, I can look at my center and see how far I had to go left and right. So we can tell from those ordered pairs that I had to go left and right 5. So if I can get that much done, I should be able to write the equation of my ellipse. Okay, so the first thing I'm going to have is my numerator. And so my numerator has the center notated in it. So it's going to be an x minus 5 squared plus y. And you could write minus 0, but we usually don't. We'll just call it y squared. These are both going to be fractions. It always equals 1. Okay, so look at your picture. Underneath the x tells me how much I go left and right. Looks like I went left and right 5. So that means underneath there, my denominator should be a 25. I look at my graph and I see that I went up and down 4. So that means underneath my y value, I should have a 16. Now these numbers in the denominator don't always have to come out nice. I threw a couple in on your assignment that maybe aren't perfect squares. That's okay. It doesn't have to be a perfect square underneath there. If it's not, you just have to kind of estimate it and see how far it would be to go up and down, left and right. All right, that's all we got. Good luck.